Okay, today we will teach you all about application of differentiation. My name is Nur Shafina Azna binti Muhammad Rasdi and my metric number is 2020815046. And my other group member is Nid Nur Amalin Nid Hasrul and Nur Ain Farhana binti Rozali. Wow, there are a lot of application of differentiations. First is related rates, second is analysis function 1, third is applied maximum and minimum problems, fourth is analysis of function 2, and last but not least is graph polynomial and rational functions. It's time to learn!
I need Nur Amalin Aisyah binti Ni Asrul, metric number 2020816238. Contents of analysis of function 1. Interval increasing and decreasing and constant function. 2. Critical number and critical point. 3. Concavity. And 4. Inflection points.
Hi, my name is Nur Ain Farhana binti Rozali. My metric number is 2020874278. So I would like to present the topic interval of increasing, decreasing, and constant function. The terms decreasing, increasing, and constant are used to describe on the interval 0, 2 and constant on the interval 4, positive, infinity. Definition 1. Based on the graph increasing on the interval negative infinity 0 and 2, 4, decreasing on the interval 0, 2 and constant on the interval 4, positive infinity. That's mean based on the graph, the first graph f is increasing on the interval if fx1 smaller fx2 whenever f1 is smaller than f2. The second graph f is decreasing on the interval if fx1 bigger fx2 whenever x1 is smaller than x2. The third graph, f is constant on the interval if fx1 equal fx2 for all points x1 and x2.
Critical number and critical point. Critical number is a value of x at which fx equal to 0. Critical points is the corresponding point at fs on the graph of f. This is the example graph of critical number. For fs equal to 3x power of 5 minus 20x power of 3. The solution is, first step, find the first derivative of f using the power of rule. Fx equal to 3x power of 5 minus 20x power of 3 and f prime x equal to 15x power of 4 minus 60 power of 2. And step 2, set the derivative equal to 0. Now we simplify it. 15x power of 2 x power of 2 minus 4 equal to 0. And we can factor x power of 2 minus 4 to x plus 2x minus 2 equal to 0. Hence, we can see that the critical is x equal to 0, x equal to minus 2 and x equal to 2. Now, critical point. Definition. We see that x equal to c is a critical point of the function fs if c exists and if either of the following are true. F prime c equal to 0 or f prime c does not exist. Example 1. Determine the critical point of fx equal to 6x power of 5 plus 33x power of 4 minus 30x power of 3 plus 100. First, we need derivative the function in order to find the critical points, and so let's get that and notice that we will factor it as much as possible to make our life easier when we go to find the critical points. So f prime x equal to cx power of 2, 5x minus 3, and x plus 5. After that, make the derivative equal to 0. So the factor form of the derivative is 6x power of 2 5x minus 3x plus 5 equal to 0. And the critical point we get is x equal to minus 5, x equal to 0 and x equal to 3 per 5.
Okay, now I will teach you about concavity. Let's meet them. And the concavity is derivative of a function f can tell us where the graph of f is increasing or decreasing. It does not reveal where the graph has a downward curve or onward curve. So I will teach you where to know the graph is downward curve or upward curves. Okay, concavity have two types, which is concave up and concave down. So as you can see, when we put water in the concave out, it will hold water, and concave down will spill water. Now difference between concave down and concave up. We can see that tangent line are rotate clockwise and the slope are decreased in concave down. You can see here, it was rotate to clockwise and the slope also decrease. While concave up, we can see that the tangent line rotate counterclockwise and the slope is increased. Okay, now we will discuss about point of inflections. Point of inflection is point P on the curve is called an inflection point. If the curve changes from concave up to concave down or concave down to concave up. As you can see in the picture, the P, when the graph is concave down, when it's achieved to the P, is turned to concave up. Same goes to the second picture. Okay, to determine the inflection point, we must find the value of x when second derivative of fx equal to 0.
Now, let's move to the activities. For the step calculation, step 1, find y-intercept and x-intercept. Step 2, determine increasing and decreasing interval. Step 3, calculate extreme point or critical point. Step 4, do concavity test, and step 5, calculate inflection point. And last step, sketch graph.
For an example, fx equal x power of 3 plus 3 power of 2 minus 9x plus 5. So step 1, we need to find x-intercept and y-intercept. So we make fx equal 0, x power of 3 plus 3x power of 2 minus 9x plus 5 equal 0. So we get x equal negative 5 and x equal 1. So the x-intercept is negative 5, 0 and 1, 0. For the y-intercept, we make x equal 0. So f0 equal 0 plus 0 minus 0 plus 5, and we get 5. So the y-intercept is 0, 5. Step 2, we use the same example. So fx equal x power of 3 plus 3x power of 2 minus 9x plus 5, and we make a differentiation. F prime x equal 3x power of 2 plus 6x minus 9. At the critical point, f prime x equal 0, and we get 3x power of 2 plus 6x minus 9 equal 0. The critical number is x equal negative 3 and x equal 1. Then we build a table. At the interval we'll fill with negative infinity, negative 3. The fx is positive, the sign is increasing. For the interval negative 3, 1, the fx is negative and the sign is decreasing. The last interval we fill with 1, positive infinity, the fx is positive, the sign we get increasing. So the increasing interval is negative infinity, negative 3, and 1 positive and one positive infinity. The decreasing interval is -3 and 1.
Step 3. Calculate extremum or critical points. To calculate critical points, we should derivative the function of fx equal to x power of 3 plus 3x power of 2 minus 9x plus 5 and f prime x equal to 3x power of 2 plus cs minus 9. And at critical points, f prime x equal to 0. We use 3x power of 2 plus cs minus 9 equal to 0. Critical number is x equal to -3 and x equal to 1. So we replace x with 3. F -3 equal to -3 power of 3 plus 3 -3 power of 2 minus 9 -3 plus 5 equal to 32. So we get -3 and 32. The other one, replace x with 1. F1 equal to 1 power of 3 plus 3, 1 power of 2 minus 9, 1 plus 5 equal to 0. And we get 1, 0. So, relative maximum point is -3 and 32, while relative minimum point is 1, 0.
Now we go to the step 4 concavity test. First we need to do the second derivative of fx. And then we got 6x plus 6. So in the critical point, f second derivative of s equal to 0. So 6x plus 6 equal to 0. We got x equal to -1. Then we do the table which is have interval fs and signs. To find fs when the interval is -infinity, -1, we need to find smaller number than -1, which is -2. So we replace -2 in the equation in the second derivative of fs. So we get the answer is -6. So is negative, fs is negative, sign is concave down. Okay, now we want to find the value of fs or the sign of fs when the interval is -1, positive infinity. We need to find bigger number than -1, which is 0. So we replace 0 in the equation in the second derivative of fs and we got the answer is 6. So it's positive. The fs is positive. Sign is the concave up. So we got the concave down is -infinity, -1. Concave up is -1, positive infinity. Now we will go to the step 5, which is calculate inflection point. First of all, we need to replace x value with -1 in the first equation, which is fx equal to x power of 3 plus 3x power of 2 minus 9x plus 5. So we got the answer is 16. And the inflection point is -1, 16. Now we go to the last step, which is sketch graph. First, we need to list all the value we get, which is x-intercept, y-intercept, maximum point, minimum point, and inflection point. Okay, as you can see, the red color of graph is the concave down and it fulfill all the value that we get. First of all, this is maximum point, which is -3, 32. It also touch the x-intercept, which is -5, 0. Then, when the graph achieve the inflection point, which is -1, 16, it will inflection to the concave up. As you can see, the black color is the concave up graph, and it also touch the x-intercept, which is 1, 0. So that's all the steps we need to follow to sketch graph.